Okay, so welcome to 5.4. We're going to look at sum and difference formulas. And here they are, basically. So if you're going to do sine of a sum, so if you have sine of angle A plus B, so it's not sine of A plus sine of B, it's sine of A plus B, then we can actually expand it so it's sine of the first cosine of the second plus cosine of the first sine of the second. What's important to note here really is that for plus and minus sine, cos, for sine, the signs are good. SIGNs are going to match in the expansion. So if you're going to do a sum, then it is a sum when you expand it. If you're going to do a difference, it's a difference when you expand it. Now for cosine, it's the opposite actually. So the signs differ in the expansion. So if it's cosine of a sum, then it's cosine, cosine, sine, sine. But if it's plus inside with the two angles, then when you expand it, it's actually subtract. And then if it's subtract, it becomes add. And then the last one is for tangents. In tangent, it's the numerator, the signs match, and the denominator, the signs differ. So for tangent, and then just remember, tangent is still sine over cosine, that hasn't changed. If you're going to do tangent of a sum of two angles, then it's tan, tan, sum over 1 tan, tan, minus. And then we have the same situation here. Okay, so let's take a look at our first problem. We want to find the exact value of, so no decimal approximations here. What we need to do is we need to take this pi over 12 and we need to turn it into radians that we know. So you want to think of adding 2 radians that give you pi over 12 or subtracting 2 radians that give you pi over 12. Okay, so the first thing I'm going to do is I'm going to start hunting. Well, pi over 12 is kind of small, so I'm thinking that I want to come up with radians that when I subtract, I get pi over 12. Now I want to subtract radians that I know. So there are an infinite amount of these. I think I'm going to do 4 pi over 12 minus 3 pi over 12. The reason why I chose them is because each one of them simplifies to something from the unit circle. So I know that 4 pi over 12 is technically pi over 3 simplified, and that 3 pi over 12 is really pi over 4 simplified. So here's what I can do. If I want to do cosine of pi over 12, which is what I'm trying to do, I'm going to replace the pi over 12, so keep the cosine. I'm going to replace it with pi over 3 minus, let's make that 3 look like a 3, minus pi over 4. Okay, now I take out my formula. It is a difference, so it is cosine, cosine. Cosine is the opposite, so if it's minus, it's plus. Sine, sine. You do want to keep track of the angles here. So if pi over 3 was my first one, then pi over 3 is first in each part of the expansion, so the two pieces. Then if the second one was pi over 4, then I want pi over 4 as the second one. Okay, now just use my knowledge about pi over 3s and pi over 4s. So I know that cosine of pi over 3 is going to give me a half. And within each one of these, so like this cosine business, that's multiplication. Cosine of pi over 4 is root 2 over 2 plus sine of pi over 3, I know is root 3 over 2 times, and then sine of pi over 4 is root 2 over 2. If I multiply, remember we multiply fractions straight across, so this is root 2 over 4 plus. If both the 3 and the 2 are inside the roots, you can actually multiply them and just keep it inside the root. So root 3 times root 2 is root 6. 2 times 2 is 4. And then I do have a common denominator. So let's go ahead and just pull it into one fraction. So root 6 plus root 2 all over 4. That is my exact answer. If I tried typing this into my calculator, so cosine of pi over 12, it's going to give you some funky decimal approximation. And that's not what we're looking for. We want the exact values of these. Okay, let's take a look at the next one. So I've got sine of negative 5 pi over 12. Okay, so I'm going to do the exact same thing here. I think I'm going to try to create an addition problem. So I have negative 5 pi over 12. Okay, so if I did negative 1 and negative 4, well, I don't know what negative 1 pi over 12 is, so that's not going to work. If I did negative 2 and negative 3, I know both of those. Those both simplify down. So negative 2 pi over 12, that turns into a version of pi over 6. And negative 3 pi over 12, that turns into a version of pi over 4. Okay, so this is going to give me negative pi over 6 plus negative pi over 4. Now, there's an infinite amount of ways that you could do this. Like, you can come up with whatever combinations you want. Just make sure that it's a pi over 2, a pi over 3, a pi over 4, or a pi over 6, something that you know from the unit circle. So I choose this. This is what I'm going to do. So if I want to do sine of negative 5 pi over 12, I am going to turn that into sine of, and the 2 that I chose was negative pi over 6 plus negative pi over 4. So I'm going to do an addition problem for sine, which is sine of the first, cosine of the second, match the positive, cosine of the first, sine of the second. And then just use what you know about the unit circle. So sine of negative pi over 6 is going to be negative half, times cosine of negative pi over 4 is going to be positive root 2 over 2, plus cosine of negative pi over 6 is going to be positive root 3 over 2. And sine of negative pi over 4 is going to be negative root 2 over 2. Okay, multiply these together. It's going to give me negative root 2 over 4 plus negative root 6 over 4. Denominators match. This getting a combination of root 2s and root 6s is kind of common. So negative root 2 minus root 6 all over 4. And that's my exact answer. Okay, so 13 pi over 12. So come up with combinations. So if I did like 1 pi over 12 and 12 pi over 12. Okay, I don't know what 1 pi over 12 is. That's not going to work. 2 and 11. I know what 2 pi over 12 is. It's pi over 6. 11 pi over 12. I don't know what that is. So 2 and 11 don't work. 3 and 10. 3 pi over 12. I know what that is. That's pi over 4. 10 pi over 12, I know what that is. That's 5 pi over 6. So I am going to take my 13 pi over 12, and I'm going to turn it into 3 pi over 12 plus 10 pi over 12. Now, you can use a different combination. Interesting to note, it doesn't matter what combination you use. If you execute the problem correctly, we get the same answer. So this is going to be pi over 4 plus 5 pi over 6. So those are the ones that I'm going to use. So I've got cosine. So cosine of pi over 4 plus 5 pi over 6. So this is going to be cosine of the first, cosine of the second, minus, remember it's opposite, cosine, cosine, sine of the first, sine of the second. And just make sure you know your unit circle. Okay, cosine of pi over 4, that's root 2 over 2, times cosine of 5 pi over 6. Well, 5 pi over 6 is left, and it's not super tall, which means this is going to be super long, negative root 3 over 2. minus, okay, sine of pi over 4 is root 2 over 2. And then I've got sine of 5 pi over 6 is just going to be a half. Notice I get this like combo root 6 and root 2 business again. So I should get negative root 6 minus root 2 all over 4. Okay, let's take a look at the next one. So I've got tangent of 7 pi over 12. So you can approach this a couple of different ways. You could do sine of 7 pi over 12 and cosine of 7 pi over 12, and then just do sine over cosine. Or you could use the tangent formula. It really doesn't matter which way you do this, you're going to get the exact same answer. Let's practice the tangent formula. Okay, so 7 pi over 12. 7 pi over 12, let's see. I'm kind of gravitating to 3 and 4. You could do 2 and 6, though. Both of those are going to work. So I'm going to go 3 pi over 12 plus 4 pi over 12, which is going to give me pi over 4 plus pi over 3. Again, not that it really matters. Like, you just come up with the combination as long as it's stuff that you know. Okay, so tangent of 7 pi over 12. I'm going to rewrite as tangent of pi over 4 plus pi over 3. And then I'm going to use the tangent expansion. So it's tan of the first, match the positive, tangent of the second, over 1, flip the positive, tangent of the first, tangent of the second. Okay. Tangent of pi over 4 is 1 plus, okay, tangent of pi over 3, that's going to be tall, which means the tangent's going to be positive root 3 over 1 minus 1 times root 3. Okay, so this is 1 plus root 3 over 1 minus root 3. Okay, so let's think about the end of this semester. At the end of this semester, you're going to have a cumulative final that is probably going to have multiple choice on it. This answer can look a ton of different ways. So I want you to know that 1 plus root 3 over 1 minus root 3 is a valid answer. Let's say hypothetically you don't see that as one of your answer choices. Well, you're also going to have a calculator. So something that you could consider doing is actually taking your answer, typing it in, which you know how to do, get your decimal approximation, and then type in the others and see which decimal approximation matches yours. This isn't the only way this answer can look. This answer can look a ton of different ways. Okay, so now we have sine of a sum, so u plus v. But in this case, we're not talking about stuff that is specifically like pi over 3s and pi over 2s and pi over 6s and so on and so forth. So what we're going to do is we're just going to draw some pictures. So we're going to let those pictures help us. So let's do a picture just for u specifically. So let's say we'll do u in green. All right, so for u, I want to be between 0 and pi over 2. So 0 and pi over 2. Got that, not a problem. So that puts me in the first quadrant. And this is u specifically. And it says that sine is 4/5. So 4/5, which means Pythagorean triple, that has to be 3. Okay, now let's draw a picture for v. I'll put v in purple. So for v, it looks like I'm supposed to be pi over 2 to pi, which puts me in the second quadrant. Call that angle v. And this says that cosine is negative 12 over 13. And then there is another Pythagorean triple. This is 5. You also have your calculator, so you can do Pythagorean theorem to find it. Okay, so let's see. This is sine of u plus v. All right, let's do our expansion. So sine of u plus V. So U and V. This is going to be sine of the first, cosine of the second, match. So it's positive, it's positive. So sine, cosine. Now we're going to do cosine of the first, sine of the second. So now I'm just going to bounce around in the picture. So if I go to the green one, sine is going to be 4/5. Times. Go to the purple one. I want to do cosine. Well, cosine is going to be negative 12/13. Bring the positive down. Go back to green. Cosine in the green is 3/5 times sine in the purple. Well, sine in the purple is 5/13. Don't simplify. Just multiply. You want the denominators to match so that we can put them together. So if I multiply the top, this is negative 48. Multiply the bottom, that's 65. Plus, straight across, 15/65. I realize 15/65 can be simplified, but don't do it because we need these denominators to be the same so that we can actually put these together. So if I put these together, this is going to give me negative 33/65. That is my answer. Same situation. So why don't you see if you can draw the pictures and then come back and check your pictures against mine. So pause it, draw the triangle for U and draw the triangle for V, then come back and make sure that our pictures match. Okay, so I drew my pictures. Now, if your sides look a little bit different than mine, that's fine. I recognized that the 1/2 and the √3/2 were from 30, 60, 90 triangles. So I just used what I knew about the unit circle and put those measurements. Now, if your measurements are slightly off than mine, then you used like opposite and hypotenuse or adjacent and hypotenuse. Don't worry about it. We're going to get the exact same thing. So if I have cosine U minus V, let's go ahead and expand this. So this is going to be cosine of the first, so cosine of the first, cosine of the second, do the opposite, if it's minus, add, and then it's going to be sine of the first, sine of the second. Okay, now we're just going to bounce back and forth between the triangles. So if I go to the green triangle, cosine is going to be negative √3/2. Times, go to the purple triangle, cosine is negative √3/2. Plus, go back to the green triangle, sine is 1/2. Times, down to purple, sine is negative 1/2. Okay, let's multiply these together. Negative and negative is positive. Okay, now √3 and √3 is technically 3 because it's √3 squared. So this is going to give me 3/4 minus 1/4. It looks like this is 2/4 for my answer. Now you can simplify it to 1/2. It's okay if you don't. Move on to the next one. Okay, same situation. So why don't you pause it, see if you can draw the pictures. Take a look at this. Tangent being 1, that sounds like a pi/4. Tangent being negative √3/3 or √3/3. That sounds like a pi/6. So why don't you see if you can draw the pictures and then come back and check. Okay, so I've got my pictures drawn. Oh, let's color code this. V is purple. Put them in the correct spots. I noticed that they were special right triangles, so I used the information that way. You don't have to in this case. Okay, so tangent, we'll get the exact same answer if we both do this correctly. So tangent of U plus V. Okay, so it's going to be tangent of the first one, match the positive, tangent of the second one over 1, flip the positive negative, tangent of the first, tangent of the second. Okay, now we're just going to bounce around. So tangent of the first one is 1 minus, tangent of the second one is root 3 over 3. It was negative, so that's where my subtraction sign comes from. And then I've got 1 minus 1 times negative root 3 over 3. Okay, this thing's a bit of a mess. We got to clean this up a little bit. So 1 minus root 3 over 3, and this one's going to be 1 plus root 3 over 3. I'm going to use techniques that we did before. So if I take a look at this, the denominator on the top is 3, so I'm going to multiply by 3 to eliminate that guy. And the denominator is 3. So I'm multiplying by 1, which is fine. I'm allowed to do that. If I'm going to distribute this, this is going to give me 3 minus those denominator cancel with the 3 I multiplied by, and this 3 plus that denominator cancels with the 3 I multiplied by. Again, these answers can look a ton of different ways. Okay, rewrite as an algebraic expression. Okay, so we've got arcs involved, so we still have the restrictions from that, but now we're doing like sum and difference of angles. So let's say that this arctan of 5x over 7, I am going to call theta, and I'm going to draw it in a picture. Then I'm going to take this arc sine of 8 over x plus 2, and I'm going to call it alpha, and I'm going to draw it in a picture. So I'm going to make these exist. But basically, I am attempting to rewrite this as cosine of theta minus alpha, which means if I do it that way, I have got the pictures, then I can use the difference of angles for cosine. So let's make the pictures work first. So arctan, all right, arctan can't be over here. I have no reason to believe the x is negative, so I'm going to put it in the positive quadrant. And this I called theta. So this is going to be my theta triangle that I bounced to. And this tells me that tangent was 5x over 7. Okay, a little bit of Pythagorean theorem. Let's figure out what this hypotenuse is. So it's going to be leg squared plus leg squared square rooted. Okay, so I've made the green stuff exist. All right, let's do blue. This was an arc sine, so not over there. I have no reason to believe that the x is negative, so I'll put it in the top right quadrant. This I called alpha. And then this one says I've got sine as 8 over x plus 2. Okay, Pythagorean theorem. It's going to be hypotenuse squared minus leg squared square rooted. Okay, now let's use the cosine formula. So I've got cosine of theta minus alpha. Okay, so this is going to be cosine, cosine, opposite, sine, sine. So I'm just going to bounce back and forth in between my triangles and write stuff down. Okay, so I'm in the green triangle, and I think I need a lot of space, so I'm going to put my equal sign over here. Okay, so I'm in my green triangle. Cosine. Cosine is going to be 7 over the square root of 25x squared plus 49. Or, how did I write this? I did 49 plus. Let's do it that way then. Not that it matters because addition is commutative. So I had the 49 first though, so let's put the 49. So 49 plus 25x squared times. Okay, now go to the blue triangle, go to alpha. Alpha cosine is going to be that big square root. X plus 2 squared minus 64. So that's the adjacent over the hypotenuse, which was x plus 2. Okay, that's just the first guy. Plus. Go back to your green. Sine is going to be 5x over the square root of 49 plus 25x squared times. Okay, now go back to blue, so go to alpha. And I want to do sine. Well, sine is going to be 8 over x plus 2. If we did this correctly, the denominators, when you multiply, are going to be the same. So we can just kind of push this all together. So my denominator, I'm going to have an x plus 2. I'm going to put it in front so I don't accidentally slide it inside the square root where it does not belong. 49 plus 25x squared. And then here I'm just going to push them together. 7 square root x plus 2 squared minus 64 plus, and then the 5x and the 8 I can actually multiply together. That's 40x. That's my answer. Don't try simplifying it. It is an absolute nightmare. Just leave it like that. Okay, we have another one. So here's what I want you to do. I want you to attempt to create the pictures. Let's do the same thing. We'll call the first guy theta, and I'm going to color code it in green. So that's going to be theta. And then this arctan of 5 over x minus 11, this is going to be alpha, and I'm going to color code it blue. I want you to see if you can draw those pictures. So I haven't even done the new stuff. This is old stuff. So draw the pictures that match those situations. Okay, so we've got the two triangles drawn. We've got theta and alpha, and now this is sine. So let's go ahead and try to expand this. So if we want to do, not blue, let's do sine of theta plus, nope, it's not plus, excuse me, this is minus. Let's get rid of that plus sign over here. Alpha. Okay, so for sine, this is sine, cosine, match it, cosine, sine. Okay, just bounce back and forth between the pictures. Okay, so if I'm going with green first, then sine is going to give me, let's move over. Actually, I probably need more space. Let's go 4 plus x squared minus 81. Squared's in the wrong place. All over 4 plus x times x minus 11 over square root x minus 11 squared plus 25 minus, we'll do 9 over 4 plus x times 5 over x minus 11 squared plus 25. Okay, so very first part, we've got sine of the first thing, so that's going to be opposite over hypotenuse times cosine of the second thing, so it's adjacent over hypotenuse. Match the sign, so if it's negative, it's still negative. Then we're going to do cosine of the first triangle, so 9 over 4 plus x, and then times sine of the second, which is 5 over. Now, if we do this correctly, those denominators, when we multiply them together, are going to be the same thing. You don't have to do anything to try to make them match. They already do match. So let's do big fraction. Put the 4 plus x out in front. Put some parentheses around it because it's the whole thing that's getting multiplied. X minus 11 squared plus 25. I'm going to erase some of that extra off the end. Okay, I'm going to take my x minus 11, put it out in front so I don't accidentally sneak it inside the square root symbol. 4 plus x squared minus 81, and then minus, well, 9 times 5 is 45. Okay. Last one. So we have a proof here. Now you have to decide which side you want to do. I think I want to do the one on the left because although it doesn't look like as much, like the right has a ton going on, but on the left-hand side, I actually see that sum and difference business. So I'm going to go ahead and use what I know. So cosine of x minus y is going to be cosine cosine sine sine over, and this is going to be sine, so sine cosine match cosine sine equals, I'm just going to carry the right hand side, so cotan x plus tan y, or 1 plus cotan x tan y. Okay, so if I look at pieces of this, so I'm just going to try to take a look at some of the chunks. I want this cosine x cosine y, so the very first thing I have, to turn into a cotangent x. Okay, so to get the cotangent x, I want cosine x over sine x. Okay, that's helpful. Then I am looking for, so let's see if we can just do that part. So let's do cosine x, cosine y. If I divide this by sine x, that'll give you my cotangent x. But if you're going to do that, you got to divide everybody. It's the same as if you are multiplying through by 1 over sine x. And this might get a little ugly, but that's okay. And understand, this isn't the only way to approach this. You can approach this a ton of different ways. So you may have seen something else to do that maybe I didn't to start this, which is totally fine. And then remember to carry the right hand side. Now the reason why I just did that was to try to get that cotangent x, which I have. Cosine x over sine x is cotangent x. So there's my cotangent x. I still have cosine y. Plus, now here my sine x is canceled. That's good. Sine y over, in the bottom, my sine x is cancel again. So I've got cosine y plus, okay, this cosine x over sine x also gives me a cotangent x. And then I still have my sine y. Okay, equals, carry down the other side. So I've got cotangent x plus tangent y all over 1 plus cotangent x tangent y. Okay, I've got my cotangent x. I have to get this tangent y. So I'm going to try to make that happen with that, since it's the second thing after the plus sign. So I'm going to divide by cosine y now. So cotangent x. And if you saw it all at once, you could actually do both of those at the same time. So this is sine y over cosine y. So everybody getting the exact same thing. So cosine y over cosine y plus cotan x sine y over cosine y. Watch your variables. Make sure that you're keeping track of your x's and your y's separately. They don't look like the same thing. Don't want to get them confused. Okay, now let's see what we got here. My cosine y's are going to cancel there, so I've got cotangent x plus sine y over cosine y. That's my tangent y that I was trying to get. Over. Those cancel. Anything divided by itself is 1. So make sure you still have the 1 there. And then I've got plus cotangent x, but now I've got this sine y over cosine y. Cotangent, whoop, that's not true. That's tangent y. Compare it to the other side. So, a whole bunch of techniques to use here. One of the things that you could do is just keep track of like, okay, well, the second thing on the numerator, I wanted this. How do I make that happen? And then remember, if you're going to multiply everybody by the exact same thing, top and bottom, that's 1. You can also divide everybody by the exact same thing because that's also technically 1.